medicine, cardiac assist devices. What is an implantable left ventricular assist device? The left ventricular assist device, LVAD, is an implantable mechanical pump that helps pump blood from the lower left chamber of your heart, the left ventricle, to the rest of your body. LVADs are used in people who have weakened hearts or heart failure. Who benefits from the left ventricular assist device? There are two groups who benefit more from LVADs. The first group consists of patients who require ventricular assistance to allow the heart to rest and recover its function after an illness or cardiac surgery. Group 2 consists of patients who have experienced a myocardial infarction, acute myocarditis, or end-stage heart disease, who are not expected to recover adequate cardiac function, and who require mechanical support as a bridge to transplantation. How does the LVAD function? The components of the device are the pump unit, control system, and a battery. The device functions by allowing blood to flow into the pump. The LVAD receives blood from the left ventricle. The device then assists the left ventricle in pumping the blood into the aorta. Pros and cons. An article written by Patrick M. McCarthy states that patients at institutions, such as the University of Michigan, who received an LVAD, were more likely to be alive 3 years after the decision was made to bridge them to transplantation. This finding can be considered to be a pro, because it provides evidence that implanting the device allows for the possibilities that will lead to an extension of life. These patients also report an acceptable quality of life. Although patients tend to have a prolonged acceptable quality of life, there are also cons that exist. Dr. Robert Brugge states in his reviews that risks of implanting the LVAD can include infection, device failure, and respiratory failure.
This device has kept Mr. Craig Lewis, a 55-year-old man with cardiac amyloidosis who had his heart removed and replaced by these two pumps, alive now for 12 days and continuing to do better. They're much smaller, they're much more robust, and they work really beautifully to support a weak left heart. But no one had ever used one to replace a heart or used two of them to treat both sides of the heart. So we realized there was going to be some arts and crafts involved. We would actually take the Dacron, put it over the form, and then wrap it in fiberglass tape and silicone. And originally we were using stuff from Home Depot, tile caulk from the bathroom department and drywall tape. And the beauty of these continuous flow pumps, there's really two things: the obvious size, but they don't wear out. We haven't had one to wear out, so they behave like the natural heart, which is one of the reasons why, to me, this is the only hope long term for a really totally implantable artificial heart that we can take off the shelf and spare patients like Mr. Lewis premature death.
Global energy crisis, nuclear power. One of the options we have for reducing carbon emissions is nuclear power. Unless our weather patterns take a drastic turn for the better, our energy production and usage will undoubtedly be a major factor in contributing to global warming through greenhouse gas emissions. There is no question that the globe has an ever-growing need for electricity supply. However, in order for nuclear power to succeed as an option, 4 critical problems must be overcome. Nuclear survival. 1. Cost. Nuclear power is not as competitive in cost as natural gas and coal. 2. Waste. We need a plan for long-term waste management. Develop a processing of spent fuel. Waste management is expensive. 3. Safety. Beyond reactor operation, we know very little about the overall fuel cycle. There is risk of serious accidents. 4. Recycling. We face international safeguards. Challenges of expanded global growth. Recycling of plutonium presents massive challenges. Addressing the future. Fossil fuel-based electricity is projected to account for more than 40% of global greenhouse gas emissions by 2020. In the US, 90% of the carbon emissions from electricity generation come from the coal-fired generators, even though this accounts for only 52% of the electricity produced. Taking nuclear power off the table as a viable alternative will prevent the global community from achieving long-term gains in the control of carbon dioxide emissions. Most countries do have some level of policy when it comes to reducing and stabilizing greenhouse gases. Countries that have increasing energy consumption will need to limit the growth of greenhouse gas emission. As we learned from the disaster in Japan, we have a difficult time planning for events that we don't imagine can actually happen. We cannot pretend that our nuclear plants are safe.